That is the periodic classification of elements. Is it? See, the 18th and the 19th century witnessed a rapid development in chemistry in all spheres of scientific activities. By 1860, what happened? The scientists had already discovered 60 elements and determined their atomic masses. That is, in the last class, we have seen what is an atomic mass. Is it right? They noticed that some elements had similar properties and hence arranged them into groups. That is, the scientists have arranged the elements into what? The groups, as we have for max, no? And that is whole numbers, natural numbers, like that, how they are divided. Like that, we have divided the elements into groups. During this period, several new elements were discovered. These new elements, what happened, were found to have different properties. It was realized that instead of studying the properties, what happened, of all these elements individually, it would be more convenient to divide them into groups. Okay, what did they do for that? They into periods in such a way that each group will contain a certain number of elements, like an array of fruits and vegetables, showing that outlines, okay, with similar properties. See, the elements which have the similar properties, and they have show a regular gradation. Okay, so scientists, what did they do? They made the several attempts to arrange these elements in a logical way, and you have studied about all these early attempts of arrangement of elements in your standard 9. Is it right? Yes. In continuation of the knowledge gained in the topic, that is periodic classification of elements in standard 9, with earlier concepts and their subsequent deliberations, you can get set to go ahead with a higher order of thinking to enhance your knowledge on the properties of elements. Okay, children? Yes, now we are going to see what do you mean by modern periodic law. That is the arrangement of the elements in the periodic table that we are going to discuss. Now, what is periodic law? That we are going to see now. Okay, Mendeleev's periodic table had some discrepancies which were difficult to overcome. For example, the atomic mass of argon, the rare gas, what is the atomic mass means? 39.95, and AMU, Armstrong unit, is greater than that of the potassium. That is, what is the atomic mass unit for this means 39.10. But argon comes before potassium in the periodic table. If elements were arranged solely according to this the increasing atomic mass, argon would appear in the position occupied by potassium in our modern periodic table. Is it right? No chemist would place the argon, a gas with no tendency to react in the same way as lithium and sodium. See, when you see the periodic table, you will easily understand, children, okay, which two highly reactive metals, lithium and sodium. Underline this. Okay, the kind of discrepancies suggested that some fundamental property other than the atomic mass must be the basis of periodicity. The fundamental property turned out to be the number of protons in an atom's nucleus, something that could not have been known by Mendeleev and his contemporaries. Okay, Henry Moseley, what did he do? A British scientist. In 1912, he discovered a new property of elements called atomic number. What did he discover? A new property of elements called as atomic number. Just underline, all of you, Henry Moseley. Henry Moseley. Okay, a British scientist. Who is he? He's a British scientist in 1912, which provided a better basis for the periodic arrangement of elements. And what did he do? It is a well known fact that the atomic number of an element is equal to the number of protons or the number of electrons present in the neutral atom of the element. The periodic law was therefore modified to frame a modern periodic law. What it states: the physical and the chemical properties of the elements or the periodic functions of their atomic numbers. What is a modern periodic law, children? The physical and the chemical properties. The addition of the chemicals or this physical properties means what? Melting point, boiling point, like that, temperature, everything. Okay, they of the elements or the periodic functions of their atomic numbers.